Hello and welcome to SudoKanard. Let's tackle the highest pointer on this round of Sudoku Grand Prix by Turkish author Can Erturan again. This is called the Squished Windoku, 121 points. This is a very difficult puzzle. The first time I solved it, it took me something like 30 minutes. So I hope that video won't be as long. I just hope I'll be able to solve it again. So the special rule is that this is an extra region Sudoku, and the extra regions are all 3 by 3 blocks centered on those shaded cells. So here we have all digits from 1 to 9. Here we have all digits from 1 to 9. And this is what we have to use to solve it. So where do you begin? I would like to begin with some fun facts of theory for this variant, which I won't use here, but which I did use on some practice puzzles that I found on Puzzle Expo, which is that the digit here is, well, obviously different from all of those. That's the rule of Sudoku. But because those 9 digits are different, it's also different from those. And those 9 digits are different, it's also different from those. So that this digit must be in one of those two cells. And similarly, this digit must be in one of those two cells. This here must be in one of those two. And this here must be in one of those two. Which I find to be quite interesting. Another point is that this digit is different from those 4 given digits. And something that I did find very late, well, I would say halfway through my first solve, is that this digit must be different from all of those. And this is where I will just remind you or teach you the ring theorem, which is somewhat interesting in this puzzle. I'm not sure that it was intended that, I'm not sure that Jan intended for us to use this theorem, which is that the digits that I've shaded in green are the same digits that are shaded in purple. Well, if some of you watch Cracking the Cryptic, they will be very familiar with this. So I will just add some very quick explanation, which is that let's add those yellow cells. If you look at the first 2 rows and the last 2 rows, you get 4 copies of all digits from 1 to 9. And that is yellow plus purple. Now, if you look at yellow plus green, you get all 5 central columns minus this region, which is 5 sets of digits from 1 to 9 minus 1 digit from one set of digits from 1 to 9, which means that yellow plus green is also 4 sets of digits from 1 to 9. So the digits in purple plus yellow are exactly the same as the digits in green plus yellow. And therefore, if you remove all the yellow parts, you remove common digits from both identical sets, and you end up with identical remainders, not reminders, but identical remainders, which means that the digits in those green cells are exactly the same digits as in those purple cells. And a consequence of that is that this central cell is different from all green digits and all purple digits, which means it can only be 7 or 9. It is probably possible to solve the puzzle without this, but I thought I would mention it because I find this very elegant. Now, you will probably tell me, what about those fives? We can place a 5 right from the beginning in this cell, which is absolutely true. Now, 5 in the central box is not in here. It's not in here. It's not in here, so 5 will be in one of those two cells. Now, if we look at this extra region, we can see that 5, because of this, are not in those cells, because of this not here, because of this not here, because of this not here. So 5 is here in this extra region. We have a 5 somewhere here, somewhere here, somewhere here. That's not very interesting. What about 1? 1 in the central region will be in one of two places. And actually, because of this one, 1 is not in here. So 1 will be here. And I did not need the theorem, the ring theorem, to exclude 1 from this cell, because 1 is excluded from this cell because of this extra region. So that is a digit. And now this region, this extra region needs a 1. It will be on one of two places here. What about 3? 3 is nowhere here. Because of this, it's nowhere here. So 3 is somewhere in those cells. Which means that for this region, 3 is nowhere here. It's nowhere here. So 3 is somewhere in one of those two cells. And for this extra region, it could be either here or there. Now, with those ones, I can place a 1 here. I can place a 1 here, a 1 there, and a 1 here. Yes, we need to do some classic Sudoku. 2. Oh, 9 is somewhere here. I will pencil mark that. Not sure that this is so useful. But something of interest about this digit is that this digit is in this region and in this region. So this digit is nowhere here. It's also nowhere here, and we know that it's not 1 or 5. So this digit will be somewhere in those cells. And likewise, it will be somewhere in those cells. Somewhere in those cells and in one of those, which is not that useful after all. But what is maybe useful is the 6 in this position. Those are from 2, 7, 8. Those are from 7, 8, 9. And the next place to look is not obvious. 6. Those 6s seem to put some constraints on 6 here. Not exactly sure how. Oh yes, for this region, 6 will be here. And now we know that the digits in those cells are 1, 6, and 9. So 1 and 9 here, 1, 6 or 9 here, 6 or 9 here. So here we get 2, 7, 8. one of those two is this digit, which is probably not that useful at this point. Here this is from 3 and 4, and here from 3, 4, 6. So this is the one from this region. But we know that this region already has a 1, so this is not 1, that's a 1, and that's the last one in the grid. Now this region will need something, not sure exactly what. With 5s here, there is a 5 in there, a 5 in there. So the 5 in this region is somewhere here, but what about the 5 in this region? We see that it's not here, it's not here, so it must be in one of those two cells, so the 5 is here. This is common to this extra region and this extra region. You get the 5 down there. Well, this is a game of patience, definitely. 6 is not here, so we get a 6 in there. Which may be interesting for this region. For this region, I'm not sure how to use that. So what about this 2? 2 is not in here, but there are lots of places where 2 can still go. Not gonna lie, I feel a little lost. This is a puzzle I've already solved, but even with that restriction, I'm really not very far into the solve. So as I mentioned earlier, this digit must be somewhere in those cells. This digit must be somewhere in those cells. This digit must be somewhere in those cells. Oh, and there is a kind of clone in this. I mean, this digit here must be in one of those two cells, so it's different from 7, which is not that much, I guess. This digit is in one of those two cells, so it must be different from 4 and 8, which looks more promising. Kind of. Although I'm really not sure where to look next. So this region still needs a lot of digits. In this region, we still need a 4. And we know that 4 is not here, because this digit is in one of those two cells. So there's a 4 in one of 3 places here. I don't remember ever using this in the cell. Am I just missing some more classic Sudoku? This is from 249. This will probably add nothing to the table. This digit is different from all of those, so it's here. And it's also different from all of those digits and those ones too, and this one too because of that. So this digit is here. So is there anything else of interest about this? This digit's not here, it's one of those, it's one of those. It's one of those. Here. So the possibilities, and now it's here. In this box, the central digit can only be here, and in this box it can only be here, which means that it is here. There again, I'm not sure that this is in the intended solution. This is what I'm finding, and now 9 must be here in this area. And I'm totally unsure that this will be of any use. But I think that this is very elegant. Oh, and now this digit is not here, it's there. So that this is 3 or 4. And there's still that ambiguity. So now what are we doing with all of that? The obvious answer is I have absolutely no idea. So here we have the second 7 or 8 and the second 3 or 4. But I still need to focus on those extra regions. There's a 3 in one of 2 cells here. This here is from 2 and 9. This here is never a 6, so this is from 2, 4, 9. And this digit is either here or there, which really doesn't help me, I'm afraid. So I took a little break in this search and I just noticed something, which is that this not being a 6 means that in this extra region, the 6 is in here, so that this is not 6. And now on this row, 6 has to be here, which means that that in this extra region, this can't be a 6 anymore, so that this is 6. It gives the 9 and the 6 here, which looks definitely looks like some kind of progress. And we can see that 6 is in all 4 extra regions now, and 9 is on this one. So we still need a 9 somewhere here, somewhere here, and those are from 4, 9. This is from 2 and 3. This is from 2, 3, and 7. I just hope that this will add some progress. So this region here needs 2, 4, 7, 8, 9. And this is not a 9. This is not a 4, it's not a 9. So this is from 2, 3, and 7. It's not 4 because there is a 4 in here. So the 4 in this region is either here or there. I'm saying that in this column, the 9 is in here, which is also the 9 in this extra region. So that won't ever be a 9, it won't ever be a 4. So this is from 3, 7, 8. And this digit must be in there. This digit is different from this one, so it must be in there. So that's not a 2 and that's not an 8. This digit is the same as that. Now this digit is in one of those. It's different from this one. So this digit is here and it's not a 2. So this digit is a 4 or 9. We're slowly getting there. And this digit is either this one or this one. So let's have a look at this one. This is from 2, 4, 8, 9. Which doesn't look that promising, to be honest. Oh, but the 2 in this column, 2 is not in the rest of this extra region, so 2 in the column is here. And 2 in this box is in one of 2 places there. We get a 2 up there somewhere. And now the 3 is in here in this region, which means that this is finally a 7 and that's a 3. And this 7 is cloned into this cell, which places a 2 and 8, a 3 there. And we know that now we know that the green is an 8. So we can place 8s in all those cells, which may bring some relief. That's a 7. Those are not 8s. 7 on this row is here. This is from 4 and 9. But this is in the same region as that. So that's the 4 and this is the 3. And this here is a 4-9 pair. That's not a 3 anymore. This here is a 9. Here we need 3 and 9, so that's a 3, that's a 9. And this is 4, this is 3. Here I need 3 and 7. This extra region already has a 4, so that's the 9, that's the 2. 9 is nowhere here. Now the missing digit in this extra region is a 2, and in this one it's a 4. So now the extra region part is over. We only need to do classic Sudoku. That's a 4. That's a 4. This column needs a 2 and a 7. This column needs a 9. This column needs a 2 and a 6. This is either 2 or 5. Those are 5 and 9. So 5 here, 9 there. That's a 2, that's a 5. 7 here, 2 and 7. That's a 2. 6 and 2. That's a 3. 7, 3. And 7 and 6. Wow, that was quite the adventure. So I can't even tell if what I did was remotely close to the intended solution. I would just say that this was really, really difficult. Thanks for watching this video. See you soon on SudoKanard.